July 2023, aviation journalists gather in Connecticut as RTX executives prepare for an earnings call that would shock the aviation world. The news hits fast and hard. Up to 1,200 Pratt & Whitney PW1000G engines need immediate inspection. Microscopic contaminants were found in powdered metal. High-pressure turbine discs faced potential catastrophic cracking. 300 aircraft were grounded. Inspections would take 8 months per engine. Airlines scrambled. Stock prices plunged. This was more than a routine engine recall. It was the collapse of aviation's most ambitious technological gamble in decades. The PW1000G, or Geared Turbofan, was a $10 billion bet on revolutionary propulsion. Engineers promised 16% fuel savings and 75% noise reduction. Airlines had placed thousands of orders. It was supposed to redefine efficient flight. Instead, it sent airlines into financial peril, grounded fleets worldwide, and turned Pratt & Whitney's crowning achievement into its costliest failure. Within months, Spirit Airlines cited these engines in their bankruptcy filings. An Indian carrier collapsed, blaming Pratt & Whitney in court. 57 airlines across 6 continents watched helplessly as aircraft sat idle from Mumbai to Miami. The crisis revealed an uncomfortable truth. Sometimes even brilliant engineering can be undone by the smallest flaw. The future can fail at the microscopic level. For decades, commercial aviation relied on conventional turbofans, CFM56s on Boeing 737s, IAE 2500s on Airbus A320s. Proven, reliable, economical, but, largely unchanged since the jet age began. Single-shaft designs rotated all components at the same speed, constrained by physics and compromise. Then CFM International launched the LEAP engine, a leap akin to the dawn of supersonic flight, cleaner, more efficient, technically refined. Airlines saw 20-year operating costs and recognized the future. Traditional turbofans suddenly seemed as outdated as propeller planes in the jet era. Fuel efficiency now determined competitive survival. Pratt & Whitney faced possible extinction. For 70 years, they had powered everything from DC-3s to F-22 Raptors and proven the JT-9D and JT-8D engines. Yet their commercial share was collapsing. CFM and GE dominated narrow bodies. Rolls-Royce led wide bodies. Pratt & Whitney needed more than incremental improvement. Robert Leduc, president of Pratt & Whitney Commercial Engines, asked the crucial question. What if the turbofan architecture itself was wrong? What if the entire industry had optimized a fundamentally flawed design for 50 years? What if the solution required abandoning conventional wisdom and embracing complexity everyone else considered impossible? The engineers, many from MIT and Stanford, had already experimented with radical designs. Geared turbofan technology had been under development since the late 1980s, with large demonstrators tested at NASA. The PW8000 around 1998 was their first serious attempt. Brilliant in theory, but, honestly, just too complex for practical use. Gearbox weight and manufacturing limits killed performance advantages, and after years of effort, the program quietly ended. Critics were merciless. It became aviation's perpetual motion machine. Could a gearbox between the fan and low-pressure turbine really work commercially? Would airlines accept the complexity? Could it be manufactured reliably? Conventional wisdom said no, too heavy, too complex, too risky. Then came ATFI, the Advanced Technology Fan Integrator, in the early 2000s. Using a PW308 core with a redesigned gearbox and single-stage fan, years of refinement brought the program closer to reality. Manufacturing technology, computational fluid dynamics, and new materials made execution possible. The math was undeniable. Letting the fan and low-pressure turbine rotate at optimal independent speeds could revolutionize efficiency. Simulations and test rigs confirmed it. The question was not theory. It was execution at commercial scale. The breakthrough came in 2008 when Pratt and Whitney launched the PurePower PWG program, a commercial product, not just a demonstrator. They invested $10 billion and committed all their engineering resources. Their philosophy was, well, pretty radical. Optimize thermodynamics over simplicity, efficiency over convention, physics over tradition. They set out to build the gearbox everyone said couldn't work. The planetary gearbox between the fan and low-pressure spool allowed each component to operate at its ideal speed. The fan at around 2,000 revolutions per minute, the turbine at about 12,000. The 3.5 to 1 gear ratio let each part reach peak performance. The result? A fan twice the size of conventional designs, spinning slower, moving more air, producing bypass ratios over 12 to 1, and dramatically reducing noise. Prototype testing actually began in 2007, and ground tests in West Palm Beach proved the concept. By July 2008, on a Boeing 747 SP testbed, pilots described unprecedented smoothness and constant thrust, unlike any conventional turbofan. But the 2023 earnings call would reveal a hidden catastrophe. The HMI Metal Powders facility in Utica, New York, had introduced microscopic contaminants into powdered nickel from 2015 to 2021. These impurities affected high-pressure turbine Stage 1 and 2 discs forged in Columbus, Georgia, causing microcracks that could, fail catastrophically. Though not intentional, a failure of quality control would cost tens of billions. Every standard inspection failed to detect the contamination until a Vietnam Airlines A321 engine exploded in 2020, triggering a full investigation. The PW1000G had been the commercial aviation efficiency champion. Orders poured in. PW1500G for the Bombardier C Series, now the Airbus A220, PW1000G for the A320neo, PW1900G for the Embraer E-Jet E2. Fuel burn dropped 16% versus legacy engines, CO2 emissions fell, and noise dropped 75%. The savings were real. An A320neo flying 3,000 hours per year saved about $1 million in fuel. Airlines like Spirit, JetBlue, Frontier, Indigo, Wizz Air, and Go Air built growth strategies around the PW1000G. Its quieter hum reduced community noise complaints, making airport expansion, politically easier. The gearbox proved reliable. 99.7% mechanical efficiency, with weight penalties offset by eliminating 6 compressor and turbine stages. By 2015, 7,000 engines worth $100 billion were committed. Spirit Airlines ran an all A320neo fleet. JetBlue dedicated their A321neo fleet. And Indigo operated the world's largest A320neo fleet exclusively with PW engines. A global maintenance ecosystem grew. Delta Tech Ops in Atlanta, Lufthansa Technik in Germany, United Tech Ops infrastructure. Billions were invested in support, all tied to one engine design. When it failed, the ecosystem collapsed. On July 25, 2023, RTX CEO Greg Hayes announced the recall 1,200 engines needed accelerated inspection. 200 required immediate removal. Each engine needed full disassembly, micro-crack detection, component replacement, and reassembly, taking about 250 to 300 days per engine. The contamination was invisible to standard inspection protocols, persisting for 5 years. The first confirmation came in 2020 on a Vietnam Airlines A321V2500. The PW1000G fleet faced the worst operational impact. Spirit Airlines grounded 36 of 123 aircraft by mid-2025. Hawaiian Airlines canceled routes. Indigo faced massive disruption. Wizz Air grounded 45 aircraft. At the peak, 350 aircraft sat idle worldwide. Financial devastation followed. RTX stock fell 15% in a single day, losing $12 billion. Pratt & Whitney reported a $46 billion operating loss in 2023, including a $5.4 billion charge. Compensation to airlines cost billions more. Spirit Airlines filed bankruptcy in 2024, citing engine groundings. Go Air in India collapsed completely. By 2025, turnaround times improved slightly, inspections reduced from 300 to 270 days. The technology itself remained sound. New PW1000G engines without contaminated parts worked flawlessly. United Airlines ordered 120 GTF-powered A321s and XLRs, confident after corrections. GTF Advantage promises further efficiency gains, continuing a lineage from the PW8000 demonstrator in 1998 to ATFI to PW1000G in 2013 and now to GTF Advantage in 2025. The geared turbofan revolution survived a manufacturing catastrophe, but damage to airlines, the industry, and Pratt & Whitney's reputation lingers. The technology succeeded. Execution failed. PW1000G was engineering audacity, proving decades of conservatism wrong, but also a lesson. Innovation without perfect execution can bankrupt airlines. Brilliance and precision must coexist. Subscribe for aviation's greatest triumphs and disasters.